All right, so for the first part of the lab, what we're going to do is we're going to observe some burning magnesium. So magnesium is a strip of metal, and we're going to use this thing right here, which is called a Bunsen burner. And the Bunsen burner, oh, shoot, it doesn't show us. You can see this hose, and it's hooked up to a pipe that goes in the wall, and it carries gas through the pipe. Gas as in methane gas that would go in the air, not like gasoline. It's not liquid, it's gaseous. So you turn the nozzle, and when you do, some of the gas starts coming up here. Now, if you have a gas stove, it's like that. It's that same type of gas. Now, in real life, when you do this, you would want to have this in your hand. This is called a striker. And what happens is you squeeze these together, and a little piece of flint goes across the metal, and it makes a spark. And so you have it in your hand because if you have gas going this whole time and then you light it, you're going to have a big ball of fire and potentially start your hair on fire or anything like that. So it's very dangerous. So we turn it on and we light our burner. Now, if you've ever seen gas burning, like the methane gas, like on your stove, you'll notice that usually it's blue, but on these Bunsen burners, we can adjust how much oxygen there is, and by doing that, we can make a different colored flame, like a lighter orangish or blue flame. All right, so then we take these tongs in our hands and we pick up the piece of magnesium. Now, I'm going to put it into the fire, and you're going to have to list a couple observations. So we put it in, and as you can see, it is a very bright white. In fact, in real life, it is so bright that if you look at it for even a split second, it can damage your eyes. All right, so it's a very bright white, and I don't know if you could hear it, probably not, but it's like, yeah, it's a real loud, intense burning. And then if we look here, what do we notice? We have a pile of ashes, and what color are they? They're blue. So did we have a chemical reaction? Oh yeah, we started out with a piece of magnesium that was silver in color. We started it on fire, and we have blue ashes. What kind of reaction do you think this is? It's actually a combustion reaction because we had fire. All right, so let's go ahead and look at our lab paper. So list some observations of burning magnesium. So we're going to do that question. And the next question says, oxygen was added to the magnesium when it burned and produced magnesium oxide. Write the chemical formula of magnesium oxide. All right, so we started out with oxygen. And oxygen, when you have it, it's O2. It's always O2 because the oxygen doesn't want to be by itself in a single atom. It makes a molecule with two atoms of oxygen bonded together. I'm just going to get rid of that green. There we go. So we have oxygen. And what did we add to the oxygen? Magnesium. And then we have an arrow. But instead of arrow, we say yield. Like a yield sign when you're driving. Yield. It means it produces. So it yields magnesium oxide. So now we need to make our formula for magnesium oxide. We have magnesium and oxygen. So we're going to look at our periodic table. Here's magnesium. What's the charge of magnesium? It's in group 2A. It's going to lose 2 electrons, so the charge is positive 2. All right, so magnesium is positive 2. And then we have oxygen. Oxygen's over here in group 6. It has 6 valence electrons, so it's going to gain 2 more for a total of 8. Remember, they always want to get rid of them and have 0 or gain more for a total of 8, whichever they're closer to. It's like rounding up or rounding down. If you have more than 4, you're going to round up and gain electrons. If you have less than 4, you're going to round down and lose electrons. So oxygen, group 6A, what is the charge? Negative 2. All right, so oxygen is negative 2. And this 2 is going to go down there as a subscript. And this 2 is going to go down there as a subscript. And so if we rewrite it, it's going to be Mg what? 2O2. So that would be magnesium oxide, or we can reduce. Do you remember what it would be if it reduces? They would both be 1s, which we don't have to write, so it would just be MgO. So our official formula, if we were going to write this as an official chemistry formula, we would say dioxide plus magnesium yields magnesium oxide. All right, so what type of reaction is this and how do you know? So we're just looking at this part because that is our official reaction. And I have one by itself, and it combines to make one thing. So which is that going to be? And let's scroll back up here because we can check our notes. So, oops, let's do this. Let's copy paste up here so we can see it all at once. Let me. Okay, so here's our reaction, and here are our examples. And it is a combustion reaction because it produced energy and heat, and there was oxygen. But which other one is it? Which other pattern does it fit? Is it synthesis, decomposition, single displacement, or double displacement? We have 1, 2 things by itself. They combine to make a total of 1 compound, so it would be a synthesis reaction. All right, so now let's go ahead and look at our next section. So part 2, now we're going to do some single displacement reactions. So we're going to use 10 drops of liquid for each, 1 scoop or all the chunks of the metal, and we are going to combine these chemicals. First of all, do you expect to see a precipitate based on what? Okay, so let's look. We are putting zinc with copper and sulfate. So if I go up here, I have sulfate and I'm putting zinc with it. So let's scroll all the way over to here. Here's zinc and sulfate. Is it going to make a precipitate? No, because it's soluble, and soluble means what? That it's going to dissolve. So we would say, no, I don't think it's going to. So, no, it will be soluble and dissolve. All right, so now we have aluminum is going to go with sulfate. So right now the copper and sulfate are together, but they're going to switch partners. And since sulfate is negative and copper is positive and aluminum's positive, which one's the aluminum going to go with? The positive copper or the negative sulfate? So it's positive, it's going to go with the negative sulfate. So we'll find sulfate and let's find aluminum right here. Is it going to make a precipitate? No, because it's going to dissolve. All right. So we'll just copy that on there. Now I have zinc, and it's with silver and nitrate. Zinc is positive, silver is positive, nitrate is negative. Who is the zinc going to go with? The negative nitrate. So let's look up here. Nitrate with zinc is way over here. Here's my zinc and my nitrate. Is it going to make a precipitate? Nope, it's going to be soluble, which means it's going to dissolve. All right, we have copper with silver and copper nitrate. Copper is positive, silver is positive, nitrate is negative. Who's the copper going to go with? The negative nitrate. So let's go back up here. Nitrate and copper is right here. Is it going to make a precipitate? No. As you can see, nitrates never make precipitates. All right. So now we're going to put them together and we're going to say, is there a chemical reaction? Well, we know that there shouldn't be any precipitates, any chunks. Can you have a chemical reaction without making chunks? Sure you can. You can make a new substance. You can change color. It can burn. There's lots of ways to have chemical reactions without precipitates. That's just one way. All right, so let's do our reactions and see what happens. So I'm adding copper sulfate to the first 2 beakers, and then to the other 2 beakers, I'm adding silver nitrate. All right, and I always like to write down what they look like, or I can take a screenshot. Let's do that. Let's zoom in a little bit so you can see a little better. And we'll take some before and after screenshots, because by doing that, we have a control. And why would I want that? Why would I want to have a control? That way I have something to compare it to at the end to see if it had a reaction or not. All right, so zinc and then aluminum and then zinc. All right, so I want zinc, zinc, and zinc goes in the third one, and the aluminum foil, and the copper. All right, and then I'm going to zoom in so we can see even a little better. And I'm going to take another screenshot so we can compare in a little bit. All right, and we're supposed to leave that sit there for 5 minutes. Okay, so that's all right. We got stuff to do over the next 5 minutes. So first of all, you can tell which one had a chemical reaction already. Beaker A, B, C, or D. Obviously it's C. And so let's fill that in. Was there a chemical reaction? Yes. What would you write for the observations? Liquid turned, I would say like a dark gray, right? So we definitely had a color change. So that's going to be our first one. And then we'll give it some time and we'll see if any of the rest react. All right, so our 5 minutes are up. I hit pause so you didn't have to wait. And let's go ahead and we will compare. So we'll take another screenshot here and go to our lab. And let's look. Beaker A. This is what it started with. This is what it looked like after we added our 2 reactants. This is the final. Would you say there was a chemical reaction? I would say no, it looks the same. All right, so chemical reaction, no. All right, and for B, that was the liquid. This is the liquid and the aluminum. This is the final. Would you say there was a chemical reaction? I'd have to say no, it looks the same. Oops. And what about our last beaker, beaker D? Here's what it was when we put it together. Here is the final reaction. Would you say there was a chemical reaction? I would have to say no. It looks the same. So we did have the one. We did have the one chemical reaction. Now, in any of these, did we have a precipitate? Well, to have a precipitate, you need to put together 2 liquids. Did we put 2 liquids together in any of these? Nope, we put together solids. We put in the chunks. So since we put together a solid and a liquid, did we make a precipitate? No. And that's what we said. We said, well, we shouldn't have any precipitates being formed. It was going to stay the chunks, and some of it might have dissolved and had a chemical reaction, but nope, we didn't have our precipitates form. Okay. So now we want to look at these chemical equations that we did. We want to make them into chemical formulas. And I said for each of these, the charge of zinc is +2. And I had to write that in there because zinc is a messy middle transition metal with multiple charges. Now, since zinc is +2, copper also has a charge of +2, which I told you guys up here in the directions. And sulfate is a polyatomic ion. It has a charge of -2. So we're going to combine them. Which one is the zinc going to go with, the copper or the sulfate? The zinc is going to go with the sulfate. So this zinc, is going to go together